Hello everyone, and welcome to Problem 13, Converting Roman Numerals to Integers on Leetcode.com. It is one of the easiest questions to answer, so we should have no problems coming up with a very quick algorithm to solve this and convert that algorithm to code. Before we begin, let's give a brief introduction to what Roman numerals are and follow that up with a few examples. Roman numerals are just strings of letters where each letter in that string has a decimal value. We can see the value of each letter if we look to the little table that we have on the left-hand side of the screen. Now, Roman numerals have two operations, additions and subtractions. Roman numeral addition happens when the current letter we are evaluating is greater than the next letter. So let's take a look here. If we have L and X, L is the very first letter, and that value according to our table is 50. X, on the other hand, according to our table, evaluates to 10. Now we have an addition here because the very first letter L, or the letter that we're currently looking at, is greater than X. And when that happens, we perform an addition, and the sum is equal to 60. Now, Roman numeral subtraction happens when the current letter we are evaluating is less than the next letter. So let's take a look at X and L. On the surface, we would probably think that this is equal to 60 as well, but that's not the case. I'll erase this for you guys. Let's evaluate each letter, starting with the first, X being 10 and L being 50. As we can see, 10 or X is less than L or 50. And in that situation, we go ahead and perform a subtraction, which would give us 40, which is the correct answer. Now, when it comes to creating a simple algorithm for this particular problem, one of the first things that's easy to spot is on the left-hand side here, we have our table, and we can easily convert that to a map or a dictionary structure. So there you have a map, our keys, and our value pairs. So there's I, which is 1, V, which is 5, X, which is 10, L, which is 50, C, which is 100, and M, which is 1000. So we want to build this map a single time and reference this map every time that we're calculating a Roman numeral. So next, we want to create three variables, all integers, called previous, current, and total. The next thing we want to do is we want to create a loop that iterates over every letter in the Roman numeral expression. So this is, of course, pseudo code, so it's not official code or anything. We'll see that later on in our code view. But we want to loop until we hit the length of this string. The next thing that we want to do is we want to do a lookup. We want to take the current letter and we want to look it up in our map to get its value. So let's say current. And let's just call this current letter. Now that means that our current value is now going to be 50. Now with Roman numerals, we want to take care of the first letter in a very special situation, a very special case. When we're dealing with the first letter, what we want to do is set that letter's value to previous and total. So let's do that here. So if first, we then take the current. Sorry about that, guys. We then assign the previous which is going to be equal to the total, which is going to be equal to the current. And in this situation, we have a previous value is now 50, and the total is now 50. So now we want to process the very next letter, which in this situation, or this problem, is X. In this example is X. So now we want to add logic for dealing with this. Current is now going to go to 10. Now we have here our current is less than our previous value. When this is the case, we want to go ahead and increment the total by the current value. So total is now 50 plus the current, which is 10, which is now 60. So what we have here works for this example of doing addition. But what about subtraction? When we have this here, X and L, when we have that expression. So let's go ahead and start over for a little bit. X is our first letter, so we do a lookup. At first, we assign all of these previous, current, and total to the same value. So current is 10, previous is 10, the total is 10. Now we have to have logic for handling L in this case. And that's when the current value is greater than the previous value. So the new current would be 50. Current is greater than previous, so we perform our subtraction. So if total is going to be equal to the total minus the previous value plus the current value minus the previous value. So let's evaluate this expression. We have total is 10, the previous is 10, plus the current, which is 50, minus the previous, which is 10, which gives us a grand total of 40. And we want to end our loop here. So this is just pseudocode, or just a quick algorithm for solving this problem. And we're going to take a look at how this looks in our code view. And I typically code my solutions in two languages, Java, which is what I've been using for most of my career. I understand it's not a very popular language. And then, of course, there's JavaScript, which, according to the cool kids, that and Python are probably the most used languages. But that's just, something that I've heard various opinions from various developers of different ages and generations. But let's go ahead and take a look at the code view. As we can see, the Roman to int function has been created. But before we get into that, let's take a look at some of the other components of the code base here. We see the map that we saw from the whiteboard view, and all the corresponding Roman numerals and their integer values are listed there. The map is in global scope, so we only have to create it one time, and we can reference it as many times as we want throughout the life of our code. We see the test arrow function here that takes data as an argument, which is just an array of objects. And within each object that's going to be represented by this variable e, each object is going to have two properties. The numeral, the actual string, the Roman numeral expression that we're going to pass to our Roman to integer function, and it's going to return us a value. We're going to print out on the log line here, we're going to print out the numeral and the value that we just got back from the Roman to integer function. And then we're going to assert, or we're going to test and make sure that the value is equal to what we expected, which is the second property of the object that is expected by the data, data array. And below we see a call to the test function and an array of all of our objects with our expected numerals and expected values as we just described. So let's go back up to the top for a minute here and let's take a look at the Roman to integer function. We can see the three variables that we discussed previously from the whiteboard view: total, current, and previous. We have an imperative style array that, not an array, I'm sorry, a loop, an imperative style loop that we are going to use to access the indexes of the actual string, and then we're going to look those up into our map. So if we see here, our if statement is exactly as we described previously, where the very first letter is a special case and previous, current, and total will all share the same value. When we are not on the very first letter, we can see that we have alternative logic here that goes to the map and gets the current value, the current letter and its value from the map. And then we see here that when the current value is greater than previous, as we discussed from the whiteboard, the total is actually ends up being a subtraction. And otherwise, we just increment the total by the current number. And we set the previous value equal to the current, and we repeat this process for as long as the length of the string. And we return our total at the bottom, which is required by the function. So the next thing we're going to do now is we're going to go ahead and run this, and just to see if everything works okay, right from IntelliJ. And as you can see, our output here, the values III, which is 3 in Roman numerals, LVIII, which is 58, MCMXCIV, which is 1994. Two examples that we saw from our whiteboard: LX, which is equal to 60, and XL, which is equal to 40. So some of these values are test values from the Leetcode.com description, and these two are just examples that we saw earlier. So now that we know that our function seems to work for the values that we've provided, I think it's time to see what it looks like from the Leetcode view. Our submission on Leetcode.com. As you can see, the code base here is pretty much the same, except that we took out our test methods. If we left those in, Leet would reject our code, so we had to remove those. And as you can see on the left-hand side, Leet accepted our code, and they found our solution to be acceptable. And they give us some nice little performance metrics over here. It beat 99.89% of other submissions in terms of running time, and in terms of memory, it beat about 51% or close to 51%. Look, guys, I'm not a god programmer here, so the solution that we have here is pretty much what I'm satisfied with. I'm not going to try to make any additional improvements to it, but I think we have a pretty solid solution to work with. And if you feel like you can improve on this design or improve on some of the things that I put out there, feel free to do so. I think Leetcode is a very good site to test your code and test your programming skills and see how good you are and how well you stack up against others. So with that said, that will conclude this Leetcode problem. I hope that you enjoyed the video. Like everyone else on YouTube says, please like or subscribe, and I will talk to you guys later.